Okay, so question number 9 says the equation of a curve is such that d square y over dx square, that is the second derivative, is equals to minus 24 over x cube. It is given that the curve has a stationary point at minus 2 comma 19. Find an expression for dy by dx. Okay, so the thing that is given is that you have a curve for which the second derivative is given, and they have also given you the stationary point. So let's integrate it to find the expression for dy by dx. So we know that the integral of d square y over dx square will give you the derivative, because this is the second derivative, so integrating it will give you the first derivative. So dy by dx will be equals to then, okay, integral of minus 24 over x cube. Now first write it in the proper form and then integrate it. So minus 24 could be taken outside the derivative integral, and you will be getting x to the power minus 3 dx. Now integrating it will give you x to the power minus 3 plus 1 over minus 3 plus 1 minus 24 times plus the constant of integration. Now, what do we know about this? Any condition that is given to us to be able to find out this constant of integration? Yes, they said that it has a stationary point. And where do we have stationary point? When we have the first derivative equals to 0, at that that gives you the stationary point. At that point, for example, you have a curve, either it's a quadratic curve or a cubic curve. At your stationary point, your dy by dx is equals to 0. So what is that stationary point? The x coordinate of the stationary point is given to be x equals to minus 2. So we'll be using this information to get the value of c. So let's find it out. Your dy by dx equals to 0 at x equals to minus 2. So 0 will be equals to, okay, one second, we haven't simplified it yet. So first simplify this further. Minus 24 x to the power minus 2 over minus 2 plus c, and that gives you 12 over x square plus c. So this is the expression for first derivative. Now, putting the first derivative equals to 0 at x equals to minus 2 will give you 12 over minus 2 square plus c, and this gives you c equals to 2 times is 4 and 4 3 times, so c equals to minus 3. So now we can write the first derivative in the proper form with constant c to be as 12 over x square plus c. Now, let's do part B of this question. Part B says, find the x coordinate of the other stationary point of the curve and determine the nature of the stationary point. So that means that, again, a mistake, it sees minus 3. Okay, the x coordinate of the other stationary point. So that means it's not a quadratic curve, rather it's a cubic curve or some other curve which is having more than one stationary point. So they are referring to that stationary point and determine the nature of the stationary point. Okay, how can you find the stationary point? We find stationary point by putting dy by dx equals to 0. So at stationary point, so let's substitute that. Now we have the complete form of the first derivative, that is 12 over x square minus 3 equals 0. That will give you your other x coordinate of stationary point. So that gives you 12 over x square equals 3, x square equals to 4, because 3 go on the other side and divide the 12, and x gives you plus minus 2. So we already have one stationary point for which x coordinate is minus 2. So the x coordinate of the other stationary point must be, this implies that x is equals to 2 for this stationary point. Now, for this stationary point, you need to find the nature, rather whether it is a maximum or a minimum. So for that, you put, for the nature of the stationary point, you substitute the x value in the second derivative to get the nature. Nature, putting x equals to 2 in d square y over dx square equals minus 24 over x cube. Okay, so this will give you d square y over dx square gives you minus 24 over 2 cube. That gives you minus 24 over 8. That gives you minus 3. It is less than 0. So that means if you have less than 0, that means you have a relative maximum. Okay, so a relative maximum is at x equals to 2. That's it. That's all about your part B. You found the other stationary point and you also found what is the nature of that stationary point. Just rearranging this a little bit. Now, referring to part C. Part C says find the equation of the curve. Okay, we have the second derivative from which we find the first derivative, and now we will be using this first derivative and integrate it to find out the equation of the curve. So let's substitute this. Integrating this will give you y rearranging it, it will become 12x to the power minus 2 minus 3 because we cannot integrate it in the denominator. So it will give you 12x to the power minus 2 plus 1 over minus 2 plus 1 minus 3x plus the constant of integration. Again, 2 minus 2 plus 1 is minus 1. So minus 12 over x, because x also has now the power minus 1, minus 3x plus c equals to y. Now, how can you find the constant of integration? You know, at the start, they have given you one point that is the stationary point of this curve. So we can use the x and y coordinates of that to find out the equation of the curve, the constant of integration for the equation of the curve. Minus 2 comma 19. So we can write as minus 2 comma 19. This point lies on curve. So we will be substituting this. Y is equals to 19 and x is equals to minus 2. Minus 3 times minus 2 plus c. Okay, so this will give you 6 plus 6 plus c. 19 minus 12 is 7. So c gives you, the value of c is 7. Okay, now your equation of the curve will turn out to be y equals minus 12 over x minus 3x plus 7. Okay, so this is your final equation of the curve. Now part D says find the equation of the normal to the curve at the point where dy by dx equals to minus 9 over 4 and x is positive. Okay, so your derivative now is equals to minus 9 over 4. Means at your curve, whatever your curve is like, most probably it's a cubic curve or whatever the curve is. At one point, you found at the stationary point your tangent. Like first, when you were talking about your curve, it's not accurately to be a cubic curve. I'm just telling you otherwise. Like we were talking about the dy by dx equals to 0. That was the equation of, like, the derivative tells you about the tangent, the slope of the tangent, and that is 0 at that point. But if they are talking about that any other point, your derivative means the gradient of the tangent is minus 9 over 4. So at that point, you need to find the equation of the normal, okay, normal to that tangent. So let's break this out and see how can we find out this. So first consider the thing that is given to us is that the derivative is equals to minus 9 over 4 for this curve. So that means this is the gradient or slope of tangent. So the gradient or tangent of the normal would be 4 over 9, the negative reciprocal, yeah, slope of normal. The second thing is x is positive. Okay, fine. And the third thing is, given that you need to just express this. Okay, how can you find this out? First thing is that you already know about the gradient. You got already the slope or the gradient. The thing that you need to find is actually now you need one point to write the equation of the normal. So for that reason, which information do we have now? We know the derivative to be this. We already know the expression for the derivative is this. So can we equate it to minus 9 over 4 to have some information about the point? Hopefully, yes. So this is your So putting this equals to minus 9 over 4. So equating these, 12 over x square minus 3 equals minus 9 over 4. Now solve this to get some x value. So that gives you 9 over 4 plus 3. Twelve minus 9 is going to be 3 over 4. So that gives you 3 over 4 equals 12 over x square. Now cross multiply. 3x square is equals to 48, and x square gives you 16. So x gives you equals to plus minus 4. Okay, one more information is given to you in the question, and that says that your x is positive. Okay, and this is here. Your x is positive. Right now, instead of, yeah. So your x is positive. Now express your answer in this form. Okay, you get your x to be positive. So this implies x will be equals to 4. Now, if you get x, so you need to find the y coordinate also. So for this reason, you need the equation of the curve, and that is here. Y is equals to, so y coordinate would be minus 12 over 4 minus 3 times 4 plus 7 minus 3 minus 12 plus 7, and that gives you minus 15 plus 7 is minus 8. So that means the point that lies on the curve is 4 comma minus 8. So this is your point. Point 4 comma minus 8 is that point on which the gradient is minus 9 over 4, and the same point, for example, just present this. This is your tangent. Okay, and this is your normal. You need to find the equation of this normal, and the point that you've just found is this point, 4 comma minus 8. Okay, and the slope, and the slope for this normal is 4 over 9. Yeah, 4 over 9, because it is the negative reciprocal of minus 9. Okay, so the slope for the normal is this. Now we can use this information to write the equation of the normal. So the equation of normal would be, I'm using a point slope form. So y minus y1 equals m times x minus x1. So y minus minus 8 is equals to 4 over 9 times x minus 4. Now cross multiply. It will give you 9 times y plus 8 equals 4 times x minus 4, 9y. So we need in the form 4x minus 9y minus 17 plus 72 is, sorry, minus 16 plus 72 is, minus 72 is minus 88 equals 0. So this is how you wrote it in the form px plus qy plus r, where your p is 4, q is minus 9, and r is minus 88. So that's all about your question number 9, where we have dealt with the second derivative, found first the first derivative, then we found the other coordinate of the stationary point, and then we found the equation of the curve, and lastly we found normal at some point where the derivative was given. So this is all about your question number 9. I hope you get it. Thank you.